polynomial function of degree n is the function of this form, where n is the non-negative integer and a sub n is not 0. The number a sub n minus 1 to a naught are all coefficients of the polynomial. The number a naught is the constant coefficient or the constant term, or we also have this as the y-intercept when you graphed it. The number a sub n is the coefficient of the highest power. It's called the leading coefficient, and the term a sub n times x to the n is called the leading term. Okay. Here we have some basic polynomial function. And here we have the graph. Well, the graph of the polynomial function is continuous. This meant that the graph has no break or hole. Moreover, the graph of the polynomial function is a smooth curve, that is, it has no corner or sharp point. So you can see the difference between the graph of non-polynomial function and the graph of polynomial function. The domain of the polynomial function is the set of all real numbers. The andBehavior polynomial is a description of what happened to the function when x becomes larger in both positive and negative direction. So let's take a look at the andBehavior of the polynomial. If the polynomial of an odd degree and the leading coefficient is positive, then at x approaches infinity, y approaches infinity to the positive side, and x go to the negative infinity, y is also go to negative infinity. Whereas the coefficient being negative, it swap around. For an even degree, if the polynomial of an even degree and the leading coefficient being positive, then the graph heads toward positive direction when x gets larger or smaller in the both positive or negative direction. The leading coefficient being negative, then y is growing to the negative infinity as x grown to either positive or negative direction. Let's describe the behavior of polynomial function and then check the answer by graphing. Okay. So we have the function here, f of x equals negative 4x negative 2x to the fourth plus 5x to the third plus 4x minus 7. Note that the leading coefficient is negative 2, that is negative. And the highest degree of the polynomial is 4, is even. This then telling us when x goes to negative infinity, y is also grown to negative infinity. When x grows to positive infinity, y is also go to negative infinity. And let's check this using the graph, and I will graph this using decimal. We'll put the graph into decimal. And as you can see in this graph, at x grown larger, the graph keeps going to negative direction. Okay. So y getting larger but in the negative direction on both ends. Let's take a look at the next one. So here, f of x equals 3x to the fifth minus 5x to the third plus 2x. So 3 is greater than 0, 5 is odd. This telling us when x go to negative infinity, y grow to negative infinity. When x grows to positive infinity, y then go to positive infinity. And so let's check the graph again using decimal. So 3x to the fifth plus 5x to the third minus 7. And as you can see in this graph, as x grows to a negative direction, y go negative, and as x go to positive direction, y grows to positive. Let's talk about the using zero to graph polynomial. Real zero polynomial. If p is a polynomial and c is a real number, then the following are equivalent. C is a 0 to p. X equals c is the solution of the equation p of x equals 0. X minus c is the factor of p of x. And c is the x-intercept of the graph of p of x. So let's take a look at an example. How is it all equivalent? So let's say we are given p of x equal to x squared minus x plus 6. And so this factor 2, x minus 6, let's change this to x minus, minus x plus 6. So this factor to x minus 3 times x plus 2. Okay, so then p of x equal to 0 when x minus 3 equal to 0, x equal 3, and x equal 2. Negative 2. So here, 3 and 2, these numbers can describe that. These here can be called as the 0 of p of x. Okay, x equals c is the solution of the equation of p of x equal to 0. So c in this case are 3 and negative 2, right? So these are the solution when we set p of x equal to 0. And again, as we can see here, x minus 3 or x minus c, and here is x plus 2 or x minus of negative 2, is a factor of p of x. And if you graph this, c is the intercept of the graph of p of x. But the intercept meant the value of x when y equal to 0. And so obviously we got this two number by setting the equation p of x equal to 0. So these are also the intercept of graph of f of x. So these four statements are equal to each other, are equivalent. Intermediate value theorem for the polynomial. If p is the polynomial function and p of a and p of b have opposite side, then there exists at least one value of c between a and b for which p of c equal to 0. So let's take a look at this simple graph. Say here you have a polynomial, and here value a and b, and let's just say p of a is positive and p of b is negative. So let's say here we get p of a, p of b, have to be negative. Okay, so in order to get from this point here to this point here, we have to cross the x-axis somehow, right? So this value is the c that referred to in the theorem. If a and b have the opposite sign, then in order to get from one point A, to point B, we have to cross the x-axis somehow, and so we get at least one value of c that make p of c equal to 0.